All right, so now let's go ahead and start solving trigonometric equations that are a little bit more complicated. So suppose you have this first equation. Let's call that the A example. And we want to have two possible solutions to this. One is the between the interval of 0 to 2 pi. The other one is the general solution, and I'm going to explain to you what that is. But let's deal with the 0 to 2 pi because we've done that in the last section. So first thing first, we have to set y equal to 0. So let's go ahead and do that. So we're going to do 0 equals to 2 sine x plus 1. We are solving for sine x. That is the variable that you're using or you have to solve for. So we have to isolate that. So what will we get? -1 equals to 2 sine x. So isolating sine x again, divide both sides by 2. And our final answer for sine x is -1/2. Great. Once you have this, you have to use your calculators, and we are using the radians mode again. In my what I do here is based on radians mode because of what we have here as well, okay? But you can go back and forth if you want between degrees and that. So what you will get is that, first of all, just remember, very quickly draw the cast so that you know where the angle, the standard position angle is. Now sine is negative in here, so this value is the sine function is negative. In which quadrant sine is negative? Well, in quadrant 3 and quadrant 4. All right, that means your standard position angle will end up being in quadrant 3 and another one will be in quadrant 4. So the first angle, you can take out your calculator and do this. So theta 1 will end up being, this is pi over 6, so it will end up being 7 pi over 6. Now that's an exact angle. Again, you can go back and check out the special triangles, okay? So this will be the standard position angle right there, because we know that the reference angle is pi over 6, so the entire thing is 7 pi over 6. Fantastic. The next one, it has to be having the same reference angle of pi over 6, but in the fourth quadrant. So the next one will be theta 2 will be what? Will be basically 12 pi over 6, which is the entire thing, but subtract away pi over 6, and that will be 11 pi over 6. Okay, so this is the second angle right there. Okay, remember 2 pi, and because if I use the pi over 6 interval, because of the special triangle, that's 12 pi over 6. I can change that to a fraction. So these are the two possible angles between 0 and 2 pi. That's it. Now remember that in this case, for example, we have the period of this function, the sine function, is 2 pi. We know that. And that means all of these values, they're going to repeat every 2 pi. So the general solution in here, we have to include, so we know that the first angle, so theta 1 will be 7 pi over 6, but it repeats itself after every single turn of one full period. So the way we write that, we say 2 pi n, and n belongs to the integer value, okay, the I integer, okay? So, and does that mean what happens if you go the other side, the other angle as well? Same idea. So theta 2, 11 pi over 6 repeats itself, plus 2 pi n, same idea again. Remember, n is just the number that it has to be integer value, okay? It's whole number, all right? Now, does it go only in positive or also goes negative? Aha. Notice that because we said n is the integer, it we don't need to include the negative in there because it's already part of the positive and negative integer, positive and negative number. So be aware of that. So just because it says plus 2 pi, that doesn't mean that the entire answer is always a negative or positive angle, okay? So n is integer, and integer runs from negative to positive, okay? Excellent. Okay, let's look at example B. Now we have a cosine equation. Let's go ahead and solve. We're going to isolate x and solve for isolate cos x and then come back. So when you solve for cos x, that's what you will get, -3/4. Great. Now we're going to go ahead and look at the cast. Okay, so here it is. Again, every time we go through it, what quadrants? You have cosine, negative. All right, now it's very important to realize this. Cosine is negative where the x value is negative. Okay, so that means it has to be called in quadrant 2 and quadrant 3. Okay, that means your standard position angle will be there. Now I use this non-special angle so that I can walk you through how you can do this. So you can use your calculator now. Simple as that. You're going to punch that number in, -3/4 cos inverse. Great. So notice that I am in radian mode right now. Okay, you could use a degree mode, but you have to change it again. So here it is, 3 divided by 4 equals, I'm going to do a negative because it has to be second function cosine, and I get 2.4189. 2.4189, that's in rad. Okay, that's your first angle, and that is in here somewhere. Okay, this is where our angle is. This is the standard position angle theta 1. 2.4189. Great. What is the next one? Well, next one will have the same reference angle. So if you take pi, so this is the reference angle that you have. What is that reference angle? This reference angle is pi minus 2.4189. Whatever that is, you will have the same value here, and then that would be the answer, plus pi. Okay, so this one will be the same reference angle as that. So let's find out what that is. So the reference angle is 0.7227. That's the reference angle right there. So pi minus 2.4189, that will give you a reference angle. It's the same reference angle. So we want to find the standard position angle in third quadrant. So all you have to do, pi plus 7.7227, and whatever that is, which would be theta 2 equals, it will be approximately 3.86 rad. All right, so now we have to come up with the general solution. All right, so we have theta 1. We're going to start with theta 1, and that was 2.4189. And then we have to remember, because of its periodic, and the period of this function is 2 pi, so we say 2 pi times n, and again n belongs to the I. Okay, that funky I for the integers number system. And then theta 2, it will be 3.86 plus 2 pi n. Remember, we are multiplying, right? N is being multiplied by 2 pi. That's the number of rotation full period that goes around, and that would be the two general solution that you have. All right, and that's it. All right, to recap, steps in solving trigonometric equations. So here there are a few of them, and not necessarily it's written in every text like this, but here it is the way I see it, and it's working for my students. So first thing that you have to do, you have to isolate the trigonometric term. Then you go ahead and use a second function mode to get the angle. Now remember, if the angle is in radians, you have to make sure your answer is in radians. If the question is asking you in degrees, then you give your answer in degrees. Then you're going to use cast to locate all the standard position angle depending on if it's positive or negative, right? And then make sure you use a reference angle. This is the crucial part. The reference angle comes really handy here. All right, so make sure you know what that is and how you can get the reference angle of any standard position angle. And once you have that, you locate the second angle if it exists. Sometimes it doesn't. There are a couple of exceptions that it does not exist, second angle doesn't exist. And then for general solution, you just pay attention to the period of the given function. In this, the last two examples that I gave you, the period was 2 pi. Great. But not all the time is 2 pi. If you have the period that is, let's say pi. So let me give you an example here just before. So y equal to sine of 2 theta. The period in here, what is the period of this function? Is pi, right? So your final answer will end up being whatever the angle that you find, whatever the alpha is, whatever the standard position, plus pi times n, not 2 pi times n, okay? And in terms of tangent, for example, tangent of theta, this has period of pi as well. So the answer in that one will be whatever the angle, the standard position angle is, plus pi n as well, right? So, and just pay attention to that, and that's basically it.